Welcome to the introductory video about charges. This video is actually broken into two parts for the CP students, and those two parts are combined for the honors students. We're starting looking at another aspect of physics. We're looking at electrical charges and how they interact. We'll go from here into circuits and move on from there. So if you notice, we jumped all the way up here to chapter 23, and this first part of the video is going to be about sections 0 through 5, and it starts off about charges. So I found this really interesting little video here that explains all about charges, and so here you go.
In this segment, I'm going to go over the basics of electric charge. The Greeks were the first ones to discover a phenomenon where if they rubbed a piece of amber with a piece of fur, they found that the amber would attract small objects. This would have seemed a bit like magic to them, but how do we explain it nowadays? How does physics account for those forces? Well, the answer is we propose a property that certain materials have called charge. And there are two types of charge, which you're probably already aware of, positive and negative. And there are two everyday particles that carry these charges. There's the proton, which carries the positive charge, and the electron, which carries the negative charge. The amount of charge on the electron is the same as the amount of charge on the proton, except the charge on the electron is negative. We call this amount of charge the electron charge, and we give it the symbol E. The charge on the electron is the smallest amount of charge you can have. You can't have half an electron worth of charge because you can't have half an electron. Also, you can only have multiples of this amount of charge, since all objects are made up of protons and electrons. Charge is given the symbol Q, and it must always be a multiple n of the electron charge. Well, how do we measure charge? We could count up all the protons and the electrons and find the difference, and then we would have the net charge on an object. But since everyday objects are made up of billions and billions of protons and electrons, it's simply not practical to count up all the proton and electron charges and find the difference. So instead, we use a big amount of charge as the standard unit. That big unit is called the coulomb and is given the symbol C. It would take 6.24 times 10 to the 18 electrons to make up 1 coulomb of charge. Or, looking at this a different way, you could say that each electron or each proton has only a tiny fraction of a coulomb of charge. 1 electron has 1.602 times 10 to the minus 19 coulombs of charge. I like to think of a coulomb as a little bucket full of electrons. It's this convenient amount. Like a kilogram of material, a coulomb of electrons is a nice, convenient way of talking about a standard unit of charge.
All right, we're back, and I wanted to show you a little demonstration here. This is one of our PHET demonstrations. You got a sweater here and you have a balloon here. And if I take that balloon and I rub it on the sweater, it shouldn't be surprising that it wants to be there. You've probably done this on your hair on a sweater. Balloon sticks to it. Question is, why? Well, what's happening here is that we're going to rub the charges from the sweater onto the balloon, making the balloon negative and making the sweater positive. And that is why they are actually attracted to each other. But what we've done is we've actually charged both the sweater and the balloon by contact and by friction. So of course these don't start without any charges. There's a whole vast array of charges on both. And what's happening when you rub them is you're rubbing the electrons, which are the ones that are free to move, from the sweater onto the balloon. You can never rub the positive or the protons off because they are in the nucleus of the atom, if you remember your chemistry from last year. So we're going to reset the balloon there. Now, Here is another topic in this section is conductors and insulators, and actually grounds. That I believe is section 4 or 5. So here's an explanation of the difference between a conductor and an insulator, and even starting in on a ground.
Some substances readily allow passage of electricity through them. Others do not. Those which allow electricity to pass through them easily are called conductors. They have electric charges, electrons, that are comparatively free to move inside the material. Metals, human and animal bodies, and earth are conductors. Most of the non-metals, like glass, porcelain, plastic, nylon, wood, offer high resistance to the passage of electricity through them. They are called insulators. When we bring a charged body in contact with the earth, all the excess charge on the body disappears by causing a momentary current to pass to the ground through the connecting conductor, such as our body. This process of sharing the charges with the earth is called grounding or earthing. Earthing provides a safety measure for electrical circuits and appliances.
Alright, so we're back. Grounds are very interesting. They're also in England, they're called earths. I'd found a very interesting video with Bill Nye that I wasn't able to get at for you. But here, if you walk around your house at some point, you will find hopefully on the outside, find a grounding stake like this. What's interesting is that you see this little stake, and it is directly connected to the ground or the earth. And that's because the charges want to get away from each other, and that's the largest possible surface for them to get away from each other. If you go to get one of these grounding spikes, they're actually very long, and they're usually made of copper or some other very low reactive but highly conductive material. Over the weekend, my son and I were in Home Depot, and we were getting something electrical. We walked by the grounding spikes, which are usually about 2 meters, 1.5 to 2 meters long. And he really wanted to go, and he just thought they were the coolest looking things. So that ends part 1 of the video, and there you go.